So, moving on to our next institution, we have Mark Gardiner representing the Nuclear Institute. So just a quick introduction from Mark. So Mark is a highly skilled chartered engineer, professionally registered with the Nuclear Institute. He's also a member of the IMechE, the IET, and Association of Project Management. With over 15 years of experience working in the nuclear sector in a variety of roles across the world, such as the UK, Germany, and Canada, Mark has had direct on-site experience with all aspects of the nuclear life cycle, from design and commissioning through to operations and then decommissioning, and is highly knowledgeable on all current fission reactor designs and has been following fusion developments. Some cool career highlights from Mark: he's had the opportunity to fly a drone inside a nuclear reactor building, and he's also designed and attaching radiation monitors to a robotic dog. Wow. And also 3D printing of nuclear fuel pellets. So,
the clicker clicks. Yeah. Okay. So good morning, everyone. Thank you, everyone, for coming on a Saturday morning. I'm Mark. I work in the nuclear industry. As you can see, I've got a few qualifications. I've also got ADHD and kind of collected them like they were Pokemon. And I think it kind of links a lot with this sort of event being collaborative. And one thing I would really like to say, don't limit yourself to one sort of profession. If you want to get involved in others, there's lots of opportunities, and you really can kind of bridge it across. I would highly recommend that. Because there's lots of cool stuff. What do I do? When people think of nuclear, of course you're going to think of The Simpsons, because why wouldn't you? Everyone does. I know I did. As it kind of says on my top, I'm a nuclear engineer. What does that actually mean? Basically, most of the time I work on decommissioning, which is a fancy way of saying dismantling. So old nuclear reactors, old nuclear sites, how to take them apart, how to safely clean up the environment. Most of these things built in the 40s, 50s, 60s, no idea how to actually dismantle them. So it's kind of, here's a big puzzle. We don't have the instruction manual anymore. We're not sure how it was built. It's slightly radioactive. There's asbestos on everything. Figure out how to take it apart. But hey, you get a load of cool robots. You get a load of cool laser scanners. You build some fancy 3D models. I really enjoy it, and I seem to be quite good at it. So how did I get into nuclear? I don't have a nuclear degree. I'm not like Carl O'Leary. I didn't also just show up like Homer. So I have a mechatronic engineering degree, which is a fancy way of saying half mechanical, half electronic. I didn't study a single nuclear module at university. I think the last time I did anything nuclear was at GCSE sort of level. Everything was kind of trained whilst I was at work. So I would say, if you want to get into the nuclear sector, you do not need a nuclear degree. There are so many sort of opportunities, and probably less than 10% of people who work in the nuclear industry actually do anything nuclear. We have all sorts of people from project management, commercial support, designers, every other sort of institute mentioned here often support new build. The likes of Hinkley Point C has tens of thousands of people there. Very, very few of them are nuclear people. Sort of some of the stuff I've done. Is there a laser on this? I think there is somewhere. Yeah. So kind of some career highlights for me. Nothing quite as cool as building an amazing bridge, but have done some fun projects. So this robot arm, so that's a hydraulic robot arm. Basically got given a challenge. Gen 2 apprentice place wanted something to help train some of their technicians on in an inactive environment. Can you build us a hydraulic manipulator completely from scratch as a bit of a challenge over 5 weeks? So that is completely designed from scratch by myself and about 10 other graduates as part of a graduate project. We literally cut all the material, we designed the hydraulic circuits, we plumbed everything in, we did the whole thing sort of together. Great project, lots of fun. Also other stuff, so yeah, that's the robot dog. Unfortunately I didn't design the robot dog, we just bought it, but I did integrate a whole load of cool radiation detectors onto it. And that is actually being used in Canada to monitor for environmental contamination in the surrounding area around the outside of one of their nuclear sites. The robot dog was chosen because if anyone's sort of familiar with Canada in the winter, it gets a little bit cold there. So that can operate at up to minus 40 Celsius. And it can get to minus 40 Celsius in the winter in Canada, which is really, really freaking cold. Some other sort of highlights. So this robot, I did design pretty much most of it anyway. So this is designed to check inside areas for radiation. Those two probes on the front will pick up alpha, which if anyone sort of has it's very hard to detect alpha. You can only pick it up with about 2 or 3 centimeters sort of range, if that. It's also incredibly dangerous if it gets inside a person. It's pretty much harmless if you leave it alone or don't get near it, but it's very dangerous if you get it inside someone. So using robots instead of people. And this other photo, I was down at the Big Bang Science Fair at the NEC in Birmingham a few years ago. BBC Breakfast happened to be there and managed to get on the breakfast show for a little bit. And then kind of linking to some of the 3D printing things. How do you explain a nuclear reactor to someone? You make a cool model of it. So yeah, 3D printed a model and you can pull it apart layer by layer by layer. It's a pretty unique design, this one. It's actually buried into the ground, so it kind of made it even more complicated. So that's about 2 hours north of Ottawa in Canada, where that site actually is. So sort of going on from that and going kind of into the sustainability worldwide. So at the moment, well, according to the internet, which is probably mostly accurate, there's 439 nuclear reactors around the world. Does anyone have any idea how many nuclear reactors we have in the UK that are operational? Slightly more? 6 at the moment. So we've currently got 6, and they are these 6. So most of them are kind of quite old. They were built sort of, I think it's sort of 70s. They're the AGR, Advanced Gas Cooled Reactors, which is these kind of, they're Torness, Asian 1 and 2, and Hartlepool. And then we also have one boiling water, one pressurized water reactor Sizewell. So they each have 2 units in them, but the classed as 1. So in about 4 or 5 years' time, how many of these will still be operational? 1. Sizewell B is the only one we're going to have operational by about 2030. The other 4 have already had massive life extensions well beyond what they're originally planning for. And the issue isn't really a safety issue, it's actually an efficiency issue. So they have carbon graphite cores and they're starting to break down. And that actually means the reactions become a lot more inefficient, so you need a lot more fuel to get less energy. So while they could operate safely longer, just the economics don't work out, and also the aging infrastructure. So we really do kind of need more power. And then kind of going on from that, so how is nuclear power sustainability? It's sustainable. So on average, how much fuel do you think a nuclear reactor uses in a year? I'm talking a big nuclear reactor. In tons. Anybody? Say a number. 10, slightly more than 10?
17.
Slightly more? 27. On average, a nuclear reactor uses 27 tons of fuel a year. That's uranium fuel. Uranium is pretty heavy. Uranium is about 20 times denser than water-ish. I'm not a chemist. So 27 tons is just over kind of a cubic meter worth of fuel. That's not very much. That's sort of a Mini Cooper Ford Fiesta-sized amount of material for an entire nuclear reactor. And then kind of going on from that, how much of it can be recycled? So we put fuel in a nuclear reactor. It's not like a coal station or other station. It burns, we call it burn. It doesn't really burn it. It transforms some of it. But how much do you think can be recovered percentage-wise if you recycle it? Anybody?
95.
Bang on. 95% of fuel can be recycled out of a nuclear reactor. So out of that 27 tons that's used, you can recover 95% of it. And then you can put it back in, and you can do that again and again and again. And that's kind of, if you compare sort of 27 tons for, well, 100 grams of uranium equals a ton of oil, or kind of all those numbers, that's kind of, the energy density out of nuclear fuel is just orders of magnitude higher than anything else, which makes it a really, really good option. And I think something to remember, we don't make uranium radioactive, it already is radioactive. but basically taking it out of the ground, pulling some energy from it safely, and then want to put it back in the ground. So it's almost, why wouldn't you? And then I think there really is the big push at the moment where the government wants electric cars. Personally, whether you like them or not, that's your own opinion. But the way the industry is going, the way the regulation is going, we're going to have more electric cars. And we need to charge them. And I think most people would like to, if you have an electric car and you can, you'd like to charge it at home overnight. That's when you get the best rate. That's kind of convenient for most people. And it's kind of, well, if you take one of the new nuclear reactors that sort of Rolls-Royce are designing, a small modular reactor, which isn't actually that small, so 300 megawatts power, which is about half what the current nuclear reactors are, so it's about half as much power. That would be enough to charge, give or take, 41,000 electric cars at the same time on a standard home charger with a few ifs and maybes, but kind of based on standard cars, things like that, and that would take about 12 hours. And all that data, like you can run the maths, it all kind of does add up, and has a few things, but it's also, well, if one nuclear reactor would charge 41,000 on a small one, or you about double that for a large one, how many cars do we think are currently on UK roads-ish? Pretty much about that, yeah. So, yeah, so cars, 36 million, total vehicles, 41 million. So that's about 1,000 times what you could charge off a single nuclear reactor. And yes, well, everyone wouldn't charge their car every night and things like that, but there's a pretty big difference on those things, and I'm not saying we should build 1,000 nuclear reactors. That's a bit crazy. It's just one of those things where you put the numbers into context. There's some pretty big numbers there. And then if you look at, so this is a really good website, it's called GridWatch. The address is there, grid.im. Kate, the person who made it is called Kate. So this provides live data, it's completely unbiased, it's pulled off National Grid. And I think kind of one of the main bits on this is really this circle here. And it shows a different breakdown, where we're getting power from, interconnectors is from other places. 83.3%. So out of all the power we use in the UK, we're currently only generating 83.3%. The other 14.2% we're importing from other countries. So at the moment, the UK does not generate all its own electricity. And if we fell out with France and they cut off our power connection, which for them would be a simple switch, our lights would go out and we wouldn't have enough power. And that's a slightly worrying position to be in. And it's really one where I'm not saying we should have nuclear at 100%. We need more of everything, well, maybe not fossil, but we need more renewables, we need more everything. And I think it really is with nuclear reactors are very, very good. If you turn them on, you put them to 100%, they like sitting at 100%, they do not like going up and down because their temperature heats up and other things. Other forms of power, like hydroelectric, is great for on-off within a minute. So it's really kind of part of we want to kind of mix this in as part of everything. And it's one where, like, this is live data, or from a couple of days ago anyway, and it'd be pretty similar if you look now. So it's just one of those things where it's a great time to be in. The nuclear sector does need a lot more things, and so at the moment there is a plan to build more nuclear reactors. How many they're going to build is debatable. If anyone follows the news, there's been an announcement at Wilver, which is on Anglesey, that Rolls-Royce, SMR have now got approval to build on their site. Which is where it's already a nuclear site where old reactors were. But kind of the main bit is by 2030, there's potentially 40,000 new jobs into the nuclear sector. So if you're looking for kind of a potential career opportunity, those jobs are there, and that number, well, after 2030, that number's not going to go away. It's probably going to go up even more. Particularly when we start looking at this really is more for new build, when we start looking more at decommissioning, environmental cleanup and future options, then we really need to do a lot more on that, because a lot of old nuclear sites, basically they took the fuel out and they've locked the door and they've just left it. And well, that's fine for now, there's not really any hazard to the environment, but that building's full of asbestos, that building's going to fall down, and we do really need to clean that up. And I think one of the main bits is a lot of those old nuclear sites are perfect places to build a new nuclear reactor, because the national grid power connections are already there to take power from a nuclear reactor. So that's sort of one where I would say, yeah, there is a lot of opportunities, and I've had an amazing time working in nuclear. I'm fortunate I worked at Sellafield nuclear site up in Cumbria for about 7-8 years. I got a bit bored there, and then I was at a conference. A guy from Canada was there. Basically went, any chance you got any jobs going in Canada at your nuclear site? A year and a half later, I moved to Canada for 3.5 years. I was in Canada, and then, we've got a project in Germany as a collaboration between Canada and Germany. We need some engineers to go to Germany. Sure, I'll go to Germany, why not? I don't speak German, but hey-ho. Spent 6 months in Hamburg, had a great time. Now back in the UK, supporting all sorts of different things. And yeah, heavily involved with the Nuclear Institute. I'm the vice chair of the Cumbria branch. I'm also on the European Nuclear Society Board of Directors. But I would say it's a great industry to work in. And you can do it kind of through any route, be that through STEM or be that through beyond that. Most people I know are not nuclear engineers, and if it's something kind of you think you'd be interested in, yeah, I would highly recommend it. And that's pretty much everything. So any questions for now, or I'll be around at the break, I'll be around at lunchtime. And I say I didn't really push Nuclear Institute. I'd say Nuclear Institute is a really good one to get involved in, sort of once you start working in nuclear, or if you want some more information. Have a look on the website. There's lots of resources there. Thank you very much. And yeah.
Okay, it's good to see you all back. Are we enjoying it so far? Yeah? Good. Okay. So we'll start the second half of the morning session. So welcoming the next professional institution, the IStructE, presented by Cameron.
Thank you very much. Right. Good morning, everybody. My name's Cameron. I'm the current chair of the IStructE's Young Members Group for the North West Hub. And I've got a small job today of introducing a little bit about our institution, our Young Members Group, which I run, and also our speaker. So, starting with our group, the Institution of Structural Engineers is the world's largest membership organisation dedicated to structural engineering. And I've been on our website, and the IStructE kindly provide 4 terms that summarise the work we do quite nicely, starting with building communities of knowledge. So our members undergo rigorous technical assessment and commit to professional development throughout their careers to ensure the professional membership we pride ourselves on is a global benchmark for safety and innovation. Upholding standards, we create and support communities of technical excellence. Our committees, panels and regional groups provide global connectivity to share knowledge. And our events, publications and training ensure our members have a firm grasp of fundamentals and keep on top of the latest technical developments. Thirdly, promoting structural engineering. We showcase the achievements of structural engineers by holding events like the Structural Awards and by acting as a source of expert comment on breaking news. We also promote the benefits of structural engineering by collaborating with other institutions to deliver events, such as this one, workshops and competitions. And finally, speaking for the profession, we share the views of engineers with government, the construction industry and other institutions, ensuring our profession makes a coherent contribution to developments in policy and practice. Now that's a terribly formal bit out of the way. I can talk about the Young Members Group that we run, local to Manchester, and it's for the ages of people who are in university and I think up to the age of about 32. And I thought the best way to show off the work is to do a nice little collage of the past 2025 that we've had. So some of the events that we run, the best example I'd say is site visits, which are essential for our young members and of course students who don't quite have the opportunity yet to go out into real construction sites and see the practical side of the buildings that they'll be working on in their careers. And I've been quite proud this year for the diverse range of construction materials and methodologies we've seen on the various sites we've visited. And this ranges from 200-year-old building refurbishments, tall concrete buildings, steel frame healthcare buildings. We've also been quite fortunate due to timings to see some landmark developments for the city centre. So I think one picture there, you see all the white screens around, is the Rylands building in the city centre, also known as the Debenhams building. We've also been looking to see the stadium expansion on the blue side of town as well. But yeah, those are really essential for especially students to get out of the classroom and see how their projects sort of materialise in the real world. And speaking of the students, we held an event in May called Meet an Engineer, where we invited 6 young professionals to give a short presentation on their early career, some of the challenges faced and how they overcame them. This was followed by a couple hours of networking where the students could ask sort of their burning questions about the field they were entering into. So I think the 50 students who attended, really benefited from that. And that wasn't the only event we had in person. We also held sketching events. So you see in the bottom right there, that's more of a sketching social where a group of us headed out into the sun, sort of draw the local architecture we've got on our doorstep. And you see the top picture there, a couple of pencils. We also held a sketching workshop for our personal development in the workplace. And finally, there have been numerous technical talks this year with a diverse range of topics, all the way from timber design, analysing structures in a seismic region, all the way over to professional indemnity insurance and the work of expert witnesses. Well, that didn't make the collage because Zoom meetings aren't terribly interesting to look at. And finally, who is introducing? It will be Dr. Zeina Al-Nabulsi, who is a driven civil structural engineer working at Atkins Realis with 7 years of industry experience. She's currently seconded to Rolls-Royce SMR, previously contributing to HBC and Sizewell projects within the EPRE Transverse team, with her early career at Dar Al-Handasa involving international projects across the MENA region. In academia, Zeina holds a PhD from the University of Warwick with published research on WAAM technology and construction. She's an active contributor to ISO and ASTM standards and has presented at global conferences including IABSC, ASTM and ICAM. Her expertise spans diverse materials and project scales with a strong focus on innovation and sustainable engineering. Zeina also sits on the Young Members panel for the ICE and the IStructE, dedicating her personal time to the betterment of both institutions. Ladies and gentlemen, Dr. Zeina Al-Nabulsi.
Thank you. Good morning, everyone. So, building a sustainable future. Is it my journey as a structural engineer, tackling climate change, or is our journey as all of us in tackling climate change, because all of us are responsible? Today I'll get the chance to talk about my journey and how I'm taking the opportunity in being an environmental advocate and structural engineer. The question that could stop us on our day-to-day work or at uni or research we're doing or whatever, what if the building we design today could help solve one of the biggest challenges of our time, which is the climate change? What if not? What if I'm designing a chemical factory or a gas station, or what if I'm doing a power new station? So we have some work to do, whatever it is. Yeah, I'm not just a structural engineer, I'm a researcher, and I always love to push myself to be an environmental advocate. My journey started with planting, collecting bins, or make sure the environments are clean and happy. And I'm from Jordan. We don't segregate plastic in Jordan, not yet. But my dad been pushing us 20 years back in making sure that not to put the plastic into the bin and just take it to the recycle, even if it's just we have to drive to drop it somewhere. So it's all started there because all of us have a responsibility to play. Over the past 10 years, my journey as structural engineer has evolved from designing large span frames, airport and university to pioneering sustainable innovation across disciplines. So I began in classical engineering, calculation, load, optimizing steel and shaping skylines, but curiosity stopped me to stop back and jump to the research, doing my PhD on 3D printing, and printed a 1 meter beam to column joint. It was steel printing, but exploring that world of how we can do things differently. And then from then, I jumped back to the industry because I felt we need to stay connected, we need to stay collaborated, whether we're in the industry or in academia. And then during that, back to the industry, the research was still in me. So I did the research on HS2 and then material they've been using and just explored how they're doing it more sustainable. But then the opportunity came. And when the opportunity came, we shouldn't say no. And I've been seconded to HPC down in Bristol. And that's my new world, was to nuclear. As Mark said, everyone can jump to this world because we have an act to do. So it was no for me, but then I said, yes, let me explore. End up on HPC and now Rolls-Royce, exploring this new world, pushing the boundaries for delivering 2030 UK vision and 2050. So in every role, I've asked, how can we do this more sustainable? Is it through design choices, material selections, or cross-sector collaboration? Sustainability is not a side project. It's the lens through which I see every challenge, and this is what we should do every day. So this is how we advocate sustainability in our role every day. I'll start with, maybe you've seen this in all IStructE's PDF files. So what's that? So our role as civil structural engineers is to think, to ask the question, do we really need to build this? But before that, I'll step back. In June 2019, structural engineering practices declared a climate emergency and committed to transforming how we design and build. It's never been because it's cheaper. We have to stop and think. But what does it really mean? We have to challenge. Looking at this graph, we see the ideal step to minimize CO2 emissions. It begins with a bold question, which we can't do to the client, but we should do we really need to build? If possible, build nothing. That's the first thing, because we don't want more CO2. And if building is unavoidable, then ask, can we build less? Can we refurbish instead of starting from scratch? When new construction is the only option, the challenge becomes, because it's now our responsibility, how do we build smarter? How do we design cleverly, build efficiently, and how to embrace the prefabrication and controlled environment to reduce waste and improve sustainability? It's not just a technical step, it's a mindset shift, because this is how we commit to help and support this environment. So, we know now we are building. It's not a choice. How can we build smartly? One of the tools to evaluate the environmental impact that we should now be all aware about is the life cycle assessment. So, when you want to buy a car, you make the comparison. Is it BMW? Is it Jeep? Is it Fiat? Why? Efficiency, time, cost, blah, blah. We start doing this. We started. So it sounds very technical, but it's about asking, what's the full story? What's the full story of that material I'm choosing? Where it's coming from? Where I am transporting it from? Is it come from Africa? Is it come from Spain? Is it come from France? Do I really want this one? Is the local one I'm dropping the commute cost or the CO2 cost out. It's now a cost. Is the material steel? Is it concrete? Is it timber? And why? Where I am staining this timber, where I'm bringing it from. Steel is strong, perfect, and recyclable. But did you know its production emits a huge amount of CO2? Concrete is cheap, perfect. But cement alone accounts for 8% of global emissions. So, something to stop and think how we can think differently. What options give us the lowest impact over its entire life cycle? So we can see the life cycle, and this is A1 to A3, where this is mainly the highest CO2 comes from, is the production stage that we need to think about. And it could take us through, am I going to refurbish that? How long is the long life for it? How I'm going to end it? What's the end result? And you calculate for each stage. So as an engineer, we have a choice because we shape the future and we need to keep that in mind. So one of the most, one of the most powerful tools we have is that embedded carbon, which is a bit nerdy bit of me. It's just like easily, you need to ask for the carbon impact for each material you're doing. You have to ask for the material, the quantity, do the math. It looks simple, it is simple once we're in it. So we want the carbon factor, so we want the material specification. And this is where we come here as a role to do whether I'm mechanical or chemical or civil or structural. So one of the most powerful tools we have is the material specification. Choosing the right material at the right time can dramatically reduce the project's carbon footprint. So I'll take steel, for example. And this is like the primary route uses iron and coal and blast furnace. The other way is using electrical gas furnace. And if we look at the numbers, the CO2 of it dropped from 2 to 1.8. It sounds 0.2 a little bit, but it's something. But also, the ideally green steel is when I am using the gas furnace and I'm using a recyclable scrap material. That will drop me to 0.04 ton of CO2. But is that really the case? Can I get scrap material every day? There's a lot of challenges, but it's just to keep questioning attitude because it's our role to make that difference. And then I did a quick math to show you with the flights. So if I'm using, look, it's 45 flights, and if I'm using the ideal green steel, it's 4 flights of CO2 emission for a carbon ton of steel. So we have an act to do, questioning. Other thing is the concrete. So the nerd bit, civils, what they do, they build civil, steel and concrete. Could be timber, could be masonry, but let's come to the concrete. Concrete is made from sand, gravel, water, additive, and cement. Cement, if you look at it in the dark yellow one, is only 12% of the mass of the concrete, but 94% of its emission. So how that starts, the major impact of more Portland cements come from its manufacturing. 80% limestone and 20% clay are mixed and ground to form the raw mix, which is then heated to 1,450 degrees Celsius. This process produces the major constituent of common cement, which is the clinker. That's good. CO2 emission from clinker production come 40% from the energy used to heat the furnace and 60% from the chemical reaction that forms clinker and releases CO2 decarbonization. So then, once we understand this, we need to step back again and ask, can I use a GGBS or can I use ash or steel ash to minimize that production that's coming from the cement? And this is our role. Again, I'm gonna stress on the questioning attitude, because we don't just shape the building, we shape their environment legacy. I jump back from the detailed classical loading calculations, civil structural work, and back to the 3D printing world, printed my beam, just because I thought at that time, and I'm talking to you, if you're still at university, explore. Stop and explore. Don't say no to opportunities. That was a detour in my career journey. 4 years at uni, doing research, traveling, finding a lab and printer to accept me and accept my ideas. And you grow and you learn. And I printed the beam. I went over the world. And then now, if not the metal 3D printing, the concrete printing is already in the market in the States and in the Middle East, and because they believe of its CO2 emission could be less. We're not wasting material. We're using it the right way, and all this. And it's just a chance to explore how things are. After exploring about this 3D printing, and printing that with the beam. And it took me, 100 working hours, like you're going layer by layer and you're testing. And yeah, so I was at uni in 2019 doing my PhD when again the IStructE has announced that declaration of us to change how we are approaching and designing. But also, I think we need to stress on that, stay stressed on that case that it's gonna affect our life safety. Climate emergency with equal importance to the life safety. We're very ambitious. We're working really hard with 2030 vision, 2050 vision not to go above the plus 1.5 degrees Celsius, but we are going. If we haven't made any steps now, we are going to go above the 1.5. So we know we're going above 1.5. We try to limit it to at least 2 degrees, because we will start seeing, if we already start seeing the climate changes. We're seeing how the weather, the summer, and all this. So it's our act to stop. In the UK, in 2021, just stressing, these are free. It's a map that's been generated as a guidance where you can have, if you're a student, get a free membership and get access to all these lovely PDFs. So in 2021, the net zero strategy was published, and it laid down plans to decarbonize different sectors of the economy: power, transport, and heating. And I think we already start touching these steps that we are seeing, from installing 600 electrical heat pumps and sale of a new fully petrol and diesel cars by 2030, capturing and storing 20 to 30 million tons of CO2 per year. We're building new stuff to capture the CO2, 100% clean power by 2030, and 81% reduction in greenhouse gas emission. So we have a lot of work to do. When we touches on the 40,000 new opportunity, we have a lot of work to act and do to become more sustainable. So back to the 100 clean energy. Now I am in the nuclear sector, because he's talking about the power plants, the fission, all that, how we're gonna get clean energy. It's me who's gonna, or the civils or the structural, we're gonna design it. We want to make sure we are building a safe environment to put all that in. But we now know the whole cycle. We're now in the building, we're gonna start the operation to build that, and to start having electricity, clean electricity, but then we're gonna go into decommissioning, and then that's the end circle of it. We're still here, right? Because in 2-3 years, we're only gonna have one left. In 2030, we need to have 10. I don't know what's the number to get that electricity clean. But now it's my role. Every day is a new day. And today is my role to question the materials, to optimize it, to build it safer, and to make question and ask and make sure we have a future that is safe, because we know we don't need to see any catastrophic event from anything. So it's our role and it's our duty to make sure we have a safe environment. And this is just touching on the different type on the nuclear power, whether it's the Hinkley, the big one, or the SMRs. And both need the same challenges. We need to make sure that radiation doesn't go. We got the right material, we have the right shielding. We're designing for any seismic, we're designing for the flooding, we're designing for any missiles with our a lot of challenges that's coming, that it's us. We're doing it to save our younger generation. So I'm just, again, stepping back and reflecting. I'm still on my journey, and I think all of you are with me in that journey, and we still have way of responsibilities to go. I don't know, I have maybe 20 years, 30 years of working days, and if you haven't started, you will join that, and we have a role to do. It's our planet. We have to think about it every day, about this plastic bottle, about the heating, about the car, about the emission, about the future. Take the opportunity, don't say no, jump, explore, and save the environment, and that's it. Thank you.